So we start by defining a path. So you first fix a topological space X, and then we want to define a path in this space X. So path in the topological space X means a continuous map from the unit interval to the space X. So you have a continuous map from the unit interval I, which we write as 0 to 1, to space X. So let us draw this. So you have a path, say from point x1 to x2, both of them are in space X, and x1 corresponds to u of 0 and x2 corresponds to u of 1. So you're going from x1 to x2. So that is basically traversing from 0 to 1 on the unit interval. So this is equivalent to homotopy of maps. So there is a homotopy of maps. So say there is a map from this point to space X. So there is a map F and there is a map G. So F gets mapped to x1, G takes this point X to x2, then the path is equivalent to homotopy between F and G. So homotopy between two maps from a point to the space. Yeah, because F will map small x to x1 and G will map small x to x2, and the homotopy is the path from x1 to x2 as you traverse the unit interval. Loop in the topological space X. You just identify both the points. So again it is a continuous map from the unit interval to space X, and u of 0 is x1 and u of 1 is also x1. Now we define the product path. So notice that this is product of paths, not a composition. So u dot v. So u dot v means you first traverse u, then you traverse v, and here t lies in the unit interval 0 to 1. So in the first half of the interval you traverse path u. So from 0 to half you traverse path u, and then in the second interval you traverse path v. Now this is very important to note, this 2t means nothing but that 2t lies between 0 and 1. Yeah, because originally when you define the path, you define its whatever goes inside it as the unit interval. So 2t has to lie between 0 and 1. Similarly 2t minus 1 has to lie between 0 and 1. And this is what you rearrange, and this should match the second t going from 0 to half or half to 1. Okay, so just to recap everything, first you travel path u from 0 to half, but you have u of 2t, so you will traverse the entire path u, and then you traverse path v from half to 1. And again this is important to note that this is not a composition. You're first traveling u and then you're traveling v, and note how it is written. If it was composition of functions, we would have written the other way around. So again it is u dot v. Now it is very important to note that this product is not associative. So let us first draw this. So say you have path u which takes you from x1 to x2, and then you have a path v which takes you to x3 from x2, and then you have path w which takes you from x3 to x4. So let us write down the product of these paths. So first you have uv and then w. So in the first half of the interval you travel the product uv and then you travel w. So second half you travel w, And that is how we will write it. For product of u and v, we will write the first half, and then for w, we will write t goes from half to 1. Now between u and v, we again have to split this interval 0 half in two parts, first for u and then for v. So for u, you will have 0 to 1 by 4 now, and v will have to travel from 1 by 4 to half. So therefore you will have u of 40, and here you have v of 40 minus 1, and finally you will have, now again I want you to notice that 40 has to lie between 0 and 1. 40 minus 1 lies between again 0 and 1. Yeah, and that corresponds to or agrees with 1 by 4 less than equal to t less than equal to half. And finally you will have path w traveling from half to 1. Again 2t minus 1 will lie between 0 and 1, and when you rearrange it, you will again get half less than equal to t less than equal to 1. Now you first travel u, and the second part is product of v and w. So half to 1 you travel v and w, and the first part you travel is 0 to half. Now again you have to split the second part into two parts. Half to 3 by 4 you travel v, and 3 by 4 to 1 you travel w. And that is what we are going to write the t as. So you will have u of 2t. So first t is from 0 to half. Again notice that 2t will lie now between 0 and 1. Then you have v of 4t minus 2. And you know precisely that t will go from half to 3 by 4. And again 4t minus 2 lies between 0 and 1. And finally you have 4t minus 3, w of 4t minus 3, and t lies between 3 by 4 and 1. So again notice how this 4t minus 3 comes. This 4t minus 3 has to lie between 0 and 1, and then this thing has to agree with this interval 3 by 4 or less than equal to t less than equal to 1. So now you can clearly see that the product is not associative. The functions you got, first travel u, then travel v, and then travel w, in both the cases are not equal to each other. But we can solve this problem because these two paths are homotopic to each other. Yeah, you first travel u, then v, and then w. These are homotopic. So if we are saying they are homotopy, we have to write a homotopy between them. So let us write down the homotopy. So you have u of 4t over 1 plus s. Again notice that 4t over 1 plus s has to lie between 0 and 1, and you rearrange this, you get 0 less than equal to t less than equal to 1 plus s by 4. Then you write v of 4t minus 1 minus s. Again 4t minus 1 minus s has to lie between 0 and 1. You rearrange this and you find that t lies between 1 plus s by 4 and 2 plus s by 4. So we need some kind of inspiration to write these homotopies. And finally you have 4t minus s minus 2 divided by 2 minus s. Again this has to lie between 0 and 1, and you rearrange this to get 2 plus s by 4 less than equal to t, which is less than equal to 1. So again I am writing the same thing, because whatever feeds into the path, it has to lie between 0 and 1, because that is the definition of path. It takes interval 0, 1 to the space. So that is why we are writing 4t minus s minus 2 divided by 2 minus s is less than equal to 1. It is same as t lying between 2 plus s by 4 and 1. Now say you plug in 0 for s. So if you plug in 0 here, you get u of 4t v of 4t minus 1, w of 2t minus 1. So you get the first path, you get this one. If you plug in s equals to 0, this is what you get. So that is the first product you get. And what if you plug in 1? If you plug in 1, you get the second product. So now plug in s equals to 1, you get this path. You get u of 2t, v of 4t minus 2, w of 4t minus 3. So now you can see that this homotopy is a continuous map, and you can see the homotopy. Now when t is 0, so if you plug in t equals to 0, you are at u of 0. Now u of 0 is x1, as you can see in the figure. So u of 0 is x1, so you are at the start of the path right here. And when you are at the end of the interval, so that is you plug in t equals to 1, you get w1. Yeah. So let me write this down more clearly. And this w1 is x4. So how do we get this w1? You are just going to see that w has this thing going into it, 4t minus s minus 2 divided by 2 minus s. Now you plug in t equals to 1 here, you get 1, because you have to operate in the interval where t is less than or equal to 1. Yeah, because 1 is only there only. So you get x4, w of 1 is x4, as you can see in the figure. So you have a perfect homotopy.